This is part of summary notes for Chapter 6 on nomenclature. This video will cover naming and writing formulas with polyatomic ions. All right, polyatomic ions are a group of nonmetals. All right, they're covalently bonded and they have an overall charge on them, usually negative. There's one positive polyatomic ion that you can scan the list below and find. All right, I'd like for you to take a moment to look at this list and think about the questions I have here on the screen. What do you notice about the bold-faced names that are below? All right, I'm going to highlight those. All right, so be thinking about what's the same, or what do you notice about these particular polyatomic ions? Okay, I hope you said they all end in ATE. Okay, they all end in ATE. Well, let's get another pen up here. All right, let's take a look at some that end in a different suffix. All right, that would go away. All right, let's take a look at these. And let's see, going down further. Okay, and one more. And what do you notice about those? They all end in ITE. Okay. All right, there are some others that actually go beyond that, and I'll point those out in just a moment. There are some exceptions on this table, and let's do those in pink. All right, notice there we have a few that end in IDE. All right, that's our cyanide and hydroxide ions. All right, they end in IDE, so that's an exception. Most of our polyatomic ions either end in ATE or ITE. All right, and then there's one other exception on the table, and that's our positive ion. Let's see if I can get a light blue color for that one. Ammonia, come on. All right, ammonium is our only positive charge ion. All right, it's still nonmetals. All right, but it behaves ionically as a polyatomic ion. All right, because it's a positive ion. All right, one other thing to point out are some prefixes that are in the chart, especially for the what is called the chlorite series. All right, we'll do those in purple. All right, we have a couple of perchlorate, hypochlorite. All right, so I'm going to do those over here. So they kind of fit into that pattern. Per and hypo. All right, the per means the least amount of oxygen in the series. I'm sorry, it's the most. I normally see this list with the least on top. Okay. All right, so hypochlorite is the least amount of oxygen, and we can see that because it's ClO negative, but the perchlorate is ClO4 negative. So it has the most oxygen in the series, and we can draw a line between the two. So we have two chlorates ending in ATE and two end in ITE. All right, and there's iodine will follow the same series, bromine will follow the same series. So that's a pattern to think about. All right, there's one other thing about this chart that I'm going to ask. What happens to the charge on a polyatomic ion when hydrogen is added? All right, and you can see those in the list here at hydrogen carbonate, hydrogen sulfate, hydrogen sulfite, and these two here. All right, what does hydrogen do when I go from carbonate to hydrogen carbonate? All right, if you said it reduces the charge by 1, you are correct. All right, -2 goes down to a -1. All right, same thing with sulfate. Sulfate 2 negative goes down to -1. Sulfite 2 negative goes down to hydrogen sulfite -1. Phosphate series is the most interesting, I think, because you can really see that pattern. Phosphate is 3 negative, hydrogen phosphate's 2 negative, dihydrogen phosphate's 1 negative. So every time you add a hydrogen, the charge goes down by 1. All right, so looking for those patterns is really important in helping you to learn the names. Okay, and always have that chart handy as you work your problems so you can be successful. Okay, but take your time to work these problems. All right, so let's write a formula for aluminum hydrogen carbonate. All right, we know aluminum is 3 plus. The hydrogen carbonate, if we look up in the list, all right, it's HCO3, and it has a negative charge. All right, one thing we do with polyatomic ions, if we need to show more than one, we're going to wrap it in parentheses. All right, so this becomes Al parentheses HCO3. All right, and then 3 on the outside, because we need 3 hydrogen carbonates to balance off the positive 3 charge on the aluminum. All right, so pause the video and try the next one, which is sodium phosphate. All right, and then come back and check your answer. All right, well, sodium phosphate is sodium Na, positive 1 charge. Phosphate is -3 charge. All right, we don't need to worry about wrapping this one in parentheses because we only need 1 in the formula, but we do need 3 of the sodiums to balance off that -3 charge on phosphate. All right, and then the next little set is to name the compounds that are there. So again, just name the elements that you see. Name the name the metal ion that's there. Name the polyatomic ion that's there, and that's all you need to do. All right, so again, pause the video, try those, and then come back and check your answers. All right, so naming these compounds, we have Na2SO4 becomes sodium sulfate. All right, no Roman numerals needed. The next one, we do need a Roman numeral, so I hope you caught that. Iron phosphate. All right, iron is the +3 version because the phosphate is a -3. So iron needs the +3 ion to balance it, and we use the Roman numeral 3 in the name. This last item, you might not have caught the fact that I had a typo there, so I've corrected the formula, but unfortunately it didn't change the name. All right, it's just my typo was there. And I'll edit that and get a corrected version up in the module. All right, so aluminum sulfate is the name of this one. All right, then one last one, just easy to do these. All right, try these as a set, just a multiple choice. And again, pause the video and then come back and check your answers. All right, so aluminum nitrate. So again, it's always good to think about your ion forms before picking out the correct formula. All right, so aluminum is 3 plus, nitrate's -1. So I'll need 3 of the nitrates wrapped in parentheses and my 3 outside the parentheses to show that I need 3 to balance off the 3 positive charge. All right, copper 2 nitrate. Well, that means I have the 2 plus ion for copper. A nitrate ion stays the same, but again, the subscript of 2 needs to be placed outside the parentheses in the formula. All right, iron 3 hydroxide. All right, iron has a 3 positive charge because of the Roman numeral. Hydroxide in the list shows me a -1 charge, and I need parentheses around the OH to show that I need 3 of those, each at a -1. To balance off 1 iron ion at a +3. And last, all right, the tin 4 hydroxide, OH is still -1. The tin has a 4 positive charge. So again, I'm going to wrap that hydroxide ion in parentheses and put a 4 outside to show 4 hydroxides, each at a -1, to balance the positive 4 on tin. Okay? All right, and this is a flow chart for helping you do, we've basically done the left side of this flow chart, all the ionic compounds. All right, there's one more mix set to try. So I'm just going to pause this a moment and pop in the answers, and you can pause it to try to work these answers and then come back and check your answers. Okay, so check your answers on this set. If you need to go back and look at any of the parts that will help you do a better job, if you missed one or two, please feel free to back up the video and help yourself there, okay? There are several of these that required no Roman numeral. That was the barium phosphate. Both of these as well, no Roman numeral was needed on those either, because they're in group 2A, as is calcium. Calcium didn't need one either. All right, so remember, location is where it's at on being able to know whether variable charges are used, and no Roman numeral is needed for your group A representative metals. All right, that ends this video.